Hello everyone, welcome to Brain Blitz Audios. In this episode of Cbse board exam, we'll be looking at previous year questions of mathematics in Cbse board exam. Today, we'll deal with questions of the 11th chapter in the grade 12 syllabus for Cbse, and the name of the chapter is 3-dimensional geometry. Let's look at our first question. Show that the lines vector r is equal to I cap plus j cap minus k cap plus lambda times 3I cap minus j cap, and vector r is equal to 4I cap minus k cap plus mu times 2I cap plus 3k cap intersect. Also find their point of intersection. So since we have r is equal to I cap plus j cap minus k cap plus lambda times 3I cap minus j cap, let's write this in terms of their components. So we're going to split them according to their components. So it will be 1 plus 3 lambda I cap, because there is 1 I cap plus 3 lambda I cap, plus, and then there's 1 minus lambda j cap, plus minus 1 k cap, and r is equal to 4I cap minus k cap plus mu times 2I cap plus 3k cap can be written as 4 plus 2 mu into I cap plus, since there is no j cap, we can write it as 0 j cap plus minus 1 plus 3 mu into k cap. So these are the equations with their components separated. So let's write this as equation 1 and this as equation 2. Now, the reason why we separated them into their components is that for two lines to intersect at a point, their respective components must be equal. So therefore, we can write that the I components must be equal. So 1 plus 3 lambda will be equal to 4 plus 2 mu. Let's write this as equation 3. And we can also write that 1 minus lambda, which is the component for j, will be equal to 0, equation 4. And we can also write that minus 1 will be equal to minus 1 plus 3 mu. Let's write that as equation number 5. So what we can do to solve is that we can use equation 4. So from equation 4, since 1 minus lambda is equal to 0, we can write lambda will be equal to 1. So now we put lambda is equal to 1 in equation 3. So it will be 1 plus 3 into 1 will be equal to 4 plus 2 mu. So then that will be 1 plus 3 is equal to 4 plus 2 mu. So 4 is equal to 4 plus 2 mu. Therefore, 2 mu will be equal to 4 minus 4. Therefore, since 2 mu is equal to 0, we can write mu is equal to 0. So lambda is equal to 1 and mu is equal to 0. Now we need to prove that the components are equal. So now we'll put mu is equal to 0 in equation 5. So put mu is equal to 0 in equation 5. So what is our equation 5? Minus 1 is equal to minus 1 plus 3 mu. So it will be minus 1 is equal to minus 1 plus 3 times 0, since mu is equal to 0. So this term gets cancelled. So we have minus 1 is equal to minus 1, which is true because both have the same component on both sides. So since both components are equal, both lines intersect at the point. So now we'll put lambda is equal to 1 in our very first equation. Remember this equation, so we're going to put it in here. So we'll put lambda is equal to 1 in equation 1. So that will be 1 plus 3 lambda. So instead of lambda, we'll put 1 I cap plus 1 minus 1 into j cap minus minus 1 into k cap. So that will be 4 I cap plus 0 j cap minus k cap. So this is the equation. So it will be the vector for the points, for the point of intersection. We found this as 4i plus 0j minus k. So therefore, 4, 0, minus 1 is the point of intersection. So therefore, we showed that these two lines intersect, and we also found the point of intersection as 4, 0, minus 1. So that ends our first question. Now, the next question. Find the angle between the lines r is equal to 2i minus 5j plus k plus lambda times 3i plus 2j plus 6k, and r is equal to 7i minus 6j minus 6k plus mu into I plus 2j plus 2k. So we can write these equations as r, we can compare it with, r is equal to a1 plus lambda b1, and r is equal to a2 plus lambda b2. So on comparing, we'll get a1 is equal to 2i minus 5j plus k. a2 is equal to 7i minus 6j minus 6k. b1 is equal to 3i plus 2j plus 6k. b2 is equal to I plus 2j plus 2k. So now we have all our 4 equations. But how do we find the angle between these two lines? So the equation for a line, for the angle between two lines, is theta is equal to cos inverse of b1 dot b2. These are vectors, so it's their dot product, divided by modulus of b1 into modulus of b2. So let's find the modulus of b1 and b2. So modulus of b1 will be 3 square 9 plus 2 square 4 plus 6 square 36, the whole root. which will be equal to root 49, which is equal to 7. And modulus of B2 will be equal to 1 squared, that's 1, plus 2 squared, that's 4, plus 2 squared, that's 4. So that will be root 9, which will be equal to 3. And let's calculate the dot product of B1 and B2. So B1 dot B2 can be calculated by using the formula A1 A2 plus B1 B2 plus C1 C2. A1 A2 are the components of I, B1 B2 are components of J, and C1 C2 are components of K from both B1 from the equation from the vectors B1 and B2. So that will be 3 times 1 plus 2 times 2 plus 6 times 2, which will be equal to 3 plus 4 plus 12, which will be equal to 19. 12 plus 4 is 16. 16 plus 3 is 19. So now let's calculate the angle. Theta is equal to cos inverse of B1 dot B2 divided by mod B1 into mod B2. So B1 dot B2 is 19, so it'll be cos inverse of 19 divided by mod B1 is 7, mod B2 is 3. So that will be equal to cos inverse of 19 divided by 7 times 3 is 21. So the angle theta is equal to cos inverse of 19 by 21. So we found the angle between these two lines. So this is our final question. Show that the lines x plus 1 by 3 is equal to y plus 3 by 5 is equal to z plus 5 by 7, and x minus 2 by 1 is equal to y minus 4 by 3 is equal to z minus 6 by 5 intersect. Also find their point of intersection. So we can write these Cartesian equations into their vector form. Therefore, the first equation will be minus I minus 3j minus 5k plus lambda times 3I plus 5j plus 7k. And the second equation will be R is equal to 2I plus 4j plus 6k plus lambda times I plus 3j plus 5k. So for lines 1 and 2 to coincide, we should note that their components must be equal. So the I component, the j component, and the k component must be equal. Let's write them with their components. So it will be minus 1 plus 3 lambda I cap plus minus 3 plus 5 lambda j cap plus minus 5 plus 7 lambda k cap for the first equation. For the second equation, it will be 2 plus mu. Let's write this as mu because we can't have lambda at the same time, so we'll write it as mu. So 2 plus mu I cap plus 4 plus 3 mu j cap plus 6 plus 5 mu into k cap. So since the components must be equal, we'll write that minus 1 plus 3 lambda will be equal to 2 plus mu. And 5 lambda minus 3, which is essentially the same as minus 3 plus 5 lambda, will be equal to 4 plus 3 mu. And we can write that 7 lambda minus 5 will be equal to 6 plus 5 mu. So let's write these as equations 1, 2, and 3. So now let's convert them. So equation 1 will become 3 lambda minus mu will be equal to 3. And 5 lambda minus 3 mu will be equal to 7. 7 lambda minus 5 mu will be equal to 11. So let's write these as equations 4, 5, and 6. So multiply equation 4 by 3. So then it will become 9 lambda minus 3 mu is equal to 9. The objective is to eliminate mu. Since the fifth equation, 5 lambda minus 3 mu is equal to 7, we made equation 4 multiplied by 3, so we'll get a 3 mu as well, so it will be cancelled. So on elimination, so that will be 9 lambda minus 3 mu is equal to 9. 5 lambda minus 3 mu is equal to 7. So that gives us 4 lambda is equal to 2. And lambda will be 2 by 4, which is equal to 1 by 2. So now put lambda is equal to 1 by 2 in equation 4. So what we'll get is 3 into 1 by 2 minus mu is equal to 3. So 3 by 2 minus mu is equal to 3. So mu will be equal to 3 by 2 minus 3. So that will be 3 minus 6 by 2. So therefore mu will be equal to minus 3 by 2. In order to prove that these two components are equal, we'll put mu is equal to minus 3 by 2 and lambda is equal to 1 by 2 in equation 6. So what is our equation 6? That is 7 lambda minus 5 mu is equal to 11. 7 lambda minus 5 mu is equal to 11. Let's put in the values. 7 into 1 by 2 minus 5 into minus 3 by 2 is equal to 11. So that is 7 by 2 plus 15 by 2 is equal to 11. 7 plus 15 is 22. So 22 by 2 is equal to 11. So that is 11 is equal to 11. So this is true. So therefore, both components are equal. And therefore, we showed that the lines intersect. Now we need to find out their point of intersection. So how do we find out their point of intersection? Easy. Let's put lambda is equal to 1 by 2 into this equation, the first one. So we'll write minus I minus 3j minus 5k plus lambda times 3i plus 5j plus 7k. And then we'll write the value of lambda. So it'll be minus I minus 3j minus 5k plus 1 by 2 times 3i plus 5j plus 7k. So therefore, we'll get minus I minus 3j minus 5k plus 3 by 2i plus 5 by 2j plus 7 by 2k. Now let's calculate. So it'll be 3 by 2 minus 1i plus 5 by 2 minus 3j plus 7 by 2 minus 5k. So that will be 3 minus 2 by 2, I, plus 5 minus 6 by 2, j, plus 7 minus 10 by 2, k. Therefore, what we'll get is 1 by 2, I, minus 1 by 2, j, minus 3 by 2, k. So this will be the position vector of the point of intersection. So our point of intersection will be equal to 1 by 2, minus 1 by 2, and minus 3 by 2. So 1 by 2, comma, minus 1 by 2, comma, minus 3 by 2 is the point of intersection. And that completes this episode of CBSE board exam. So we'll be back with more questions of the same chapter because this video is very short and therefore we cannot do all questions in one go. So I'll attach more of our episodes and the playlist in the description down below. So please do click on them and watch the previous episodes. And Brain Blitz Audios is a free educational channel delivering quality content. To be a part of our journey, please subscribe to our channel. So until the next episode, take care, stay safe, ta-ta for now.